All right, here are the notes for 5.5. So now we're going to be talking about negative exponents, and at the end we're going to do a little bit with scientific notation. So just really quickly, here are our exponent rules again. And then we're going to add the two negative exponent rules. So when you're multiplying with like bases, remember the rule is that you add the exponents. If we go to the right, anything to the 0 power is 1. Here, if I'm taking a monomial and I'm raising it to a power, I multiply the powers. Let's go down here next. Remember, if you have a monomial inside the parentheses, that exponent has to be applied to every single part of the monomial. Oops. Yep. Same thing with the fraction. That power or exponent has to be applied to everything. When you're dividing with like bases, remember you subtract the exponents, but remember we also talked about thinking about it as canceling. I think that's going to be easier for you. So now our last three rules up here have to do with negative exponents. So negative exponents move things from the top of the fraction to the bottom and vice versa. So the definition of x to the negative 1, or x to the negative n, is it's 1 over x to the n. Think of it this way. This is really over 1. So that negative exponent moves that part to the bottom, and the negative exponent changes to a positive exponent. If we look at this, notice where the negative exponent is. It's on the bottom, so that negative exponent, that part, is going to move to the top, and then the exponent will become positive. Well, let's look at the last one and take it step by step. So using this rule over here, that exponent has to be applied to both the top and the bottom. And then let's see what happens. So again, this x to the negative n is going to go downstairs and become x to the n. And this y to the negative n is going to go upstairs and become y to the n. So when you have a fraction being raised to a negative exponent, the fraction flips. So let's do our examples. Simplify, leaving no negative exponents. So if I have 3 to the negative 4th, that's really 1 over 3 to the positive 4th, which simplifies down to 1 over 81. Be careful with b. What's being raised to the negative exponent? Not the 7, just the x. So the 7 will stay on top of the fraction, and it's only the x that will move downstairs and become x to the 4th. Now be careful for this one. Now this is a plus sign, so this is a binomial, so you take each one of these separately. So 4 to the negative 1 becomes 1/4, plus 3 to the negative 1 becomes 1/3. And then we can add these two fractions by getting a common denominator, which would be 12. So top and bottom here would have to be multiplied by 3. Top and bottom for the second fraction would have to multiply by 4. So I'd end up with 3/12 plus 4/12, which adds together to give me 7/12. If you look at D, the whole negative 4th is being raised to the negative 2 power. So this is going to become 1 over negative 4 squared, which is 1 over, and negative 4 squared is going to be 16. So you see we're getting a lot of practice with the negative exponents. Now notice how this y to the negative 7th is on the bottom, so it's going to go upstairs and become y to the 7th. Well, look what happens here. This x to the negative 5th will go downstairs and become x to the positive 5th. This y to the negative 2 will go upstairs and become y to the 2nd. Now if we look at G, what's going to happen with this x to another? Well, let's look at the x first. This is x to the first. That's not going anywhere, is it? It's being raised to a positive exponent. Only negative exponent things move. This x to the negative 5 is going to go upstairs and become x to the 5th. So you have x to the first times x to the 5th, and that just leaves a 1 underneath. So my final answer when I multiply these would be x to the 6th power. Remembering when you multiply, you add the exponents. Now if I go ahead and if I look at h, this a squared isn't going to move, but this a to the negative 10th will go downstairs and become a to the 10th. So what we end up with is 1 over, because you have to have a 1 left, and it would be a squared times a to the 10th, which of course is 1 over a to the 12th. So don't forget about the fact that you have to have a 1 in the numerator here. You didn't have to leave the 1 in the denominator because anything divided by 1 is simply itself. Okay, so we know that this negative 2 has to be applied to both the top and the bottom, so that's 3 to the negative 2 over 5 to the negative 2. But this 3 to the negative 2 is going to go downstairs and become 3 squared. And this 5 to the negative 2 will go upstairs and become 5 squared, giving us 25 over 9. All right, let's look at J. So again, this negative 5 has to be applied to both the A and the B. And remember, when we're raising a monomial to a power, we multiply the powers. So this would become A to the negative 4 times negative 5. That's 20th. And B to the negative 35th. Now we have a negative exponent that we have to take care of. The a to the 20th is going to stay on top of the fraction because that's being raised to a positive exponent. But this b to the negative 35th will go downstairs and become b to the positive 35th. A couple more. If we look at k here, so now again, the negative 2 has to be applied to everything, including the 9. So this would be 9 to the negative 2, x to the negative 6th over y to the negative 2. And because everything's being changed or being raised to a negative exponent, that means everything is going to change position. So this 9 to the negative 2 will go downstairs and become 9 squared. X to the negative 6th goes downstairs and becomes x to the 6th. And downstairs we have y to the negative 2 that's going to go upstairs and become y squared. So we're going to have y squared over 81x to the 6th. Why don't you guys go ahead and try L, and then when you're done, come back and I'll go through it with you. Okay, so we have to bring this 2 into everything. So this is going to be 3 squared x to the 6th, y to the negative 8th, over x to the 8th, y to the negative 4th. So I would start like that. Now we can start moving things around. Remember, anything to a negative exponent, it's going to change the part of the fraction. So by the way, 3 squared is 9. That's going to stay there. X to the 6th is going to stay there because it's being raised to a positive exponent. Y to the negative 8th is going to go downstairs. We have x to the 8th downstairs. That's going to stay. And then this y to the negative 4th will go upstairs and become y to the 4th. Oops, there should be a positive 8. My bad there. All right, so now you can see that we have some canceling that we can do. Look, we have an x to the 6th and an on the top and an x to the 8th on the bottom. So this takes us back to the beginning of chapter 5. So these 6 x's will cancel with 6 of the 8 down below, leaving me with x squared in the bottom. We have a y to the 4th and a y to the 8th. So all of these y's, y to the 4th, will cancel with 4 of the 8 downstairs, leaving me with y to the 4th power. So when all is said and done, the 9 is the only thing that's left in the top, and we have on the bottom x squared y to the 4th. All right, so that's lots of practice with negative exponents. Now let's talk about scientific notation. So first of all, scientific notation is the one and only place in mathematics where we leave a negative exponent. Otherwise, negative exponent should disappear. So by definition, scientific notation is a number a times, and this is also the only place where we use an x for multiplication, and I think that's probably because scientific notation is more science-y than mathy. So it's a number a times 10 to a power n, where your a, the absolute value of a, has to be a number between 1 and 10. It can be 1, the equal to sign. It can't be 10. Okay, so what scientific notation is it's really just a shortcut of writing really big numbers that you see all the time in science or really small numbers. So if we look at example 2, what we're going to do is we're going to take the number that I'm giving you and we're going to change it to the other form. So we can see for 2a, this is in scientific notation. We're going to take it out of scientific notation. Now, whenever you see a negative exponent, it basically means we're going to be talking about a small number. So the way we're going to take this and take it out of scientific notation is we're going to take the decimal, and because we're talking about a small number, we're going to move it to the left, because you can agree that that's going to make it much smaller, and we're going to move it to the left 8 places. So it's going to be negative. The negative stays, point, and you'll have 1, 2, 3, 4, 5, 6, 7 zeros, and then your 5 and your 7. So we've taken the decimal that was here and we moved it 1, 2, 3, 4, 5, 6, 7, 8 places to the left. This is that number in standard form, or not in scientific notation. If we look at B, 1.5 times 10 to the positive 5th, so this means we're talking about a larger number. So we're going to move our decimal to the right 5 places. So that would be 1, 5, and then we would have 4 zeros. And that would be 150,000. C is in standard notation, and we have to change it to scientific notation. So now again, we're talking about a large number here, so that should, in your head, think positive exponent. So how would I get it so this number is between 1 and 10? So I start moving my decimal, 1, 2, 3, 4. Well, that's 260. That's not between 1 and 10. 5 places, that's 26. That's not between 1 and 10. One more place would be 6 places, which would make the number 2.6. That is a number between 1 and 10. So my A is 2.6 times 10 to the, and it's going to be a positive 6 because I moved my decimal 6 places. For D, again, you're looking at a small number. We're going to move our decimal to the right until I get to a number between 1 and 10. So 1, 2, 3 places gives me 0.88. That is smaller than 1, so I'm not there yet. 4, so that's 1, 2, 4 places gives me 8.8. There's my A, my number between 1 and 10. So it's going to be 8.8 times 10 to the -4 power. So we can multiply and divide using scientific notation, which is what we're going to do here. So when you multiply or divide by that matter, we take the numbers in front of the multiplication symbols. Think of those as your coefficients. This is a multiplication problem, so I'm going to multiply 9 times 4, which is 36, times 10 to the, use your exponent rules. When you multiply, see how the bases are the same. What does the exponent rule say you do to the exponents? You add them. So this would be 36 times 10 to the negative 2. But notice that is not in scientific notation. My A is not between 1 and 10. So I need to move my decimal to get this number to be 1 and 10. So here's a little hint for you. I would have to move it one place to the left, making this number smaller. So I go to my exponent and I add 1, making my exponent 1 bigger. So you do the opposite. So this would be 3.6 times 10 to the negative 1. Well, let's look at this. So it's a division problem. So 8 divided by 2 is 4 times 10 to the, and again, what does the exponent rule say you do when you're dividing? You subtract. So 4 minus negative 3 is going to be 7. You could also think of it as the fact that this negative exponent moves upstairs with the 4 and gets multiplied, and then you would add your exponents. This is in scientific notation because my A is a number between 1 and 10, so I don't have to tweak it. All right, let's look at the two-story problems. They're not going to be that difficult, so don't panic when you see all the words. So the thickness of a penny is 6 times 10 to the negative 2 inches. How many pennies would have to be stacked to equal the height of the Empire State Building, which is 1.5 times 10 to the 4th inches? So how would I figure out how many of these it would take to get to here? How would I do that? Well, I would have to divide 1.5 times 10 to the 4th by 6 times 10 to the negative 2. That will tell me how many of these there are in here. Okay, well, so let's go ahead and let's divide 1.5 divided by 6. That's going to give me 0.25 times 10 to the 4 minus negative 2 is to the 6th power. Think of it as the negative 2 goes upstairs. Okay, so now we should state our answer in scientific notation, even though it doesn't say to. Let's go ahead and do that. Actually, it says how many pennies. So in my opinion, it would make more sense if we just take this out of scientific notation. Because this is a positive number, we're going to take this decimal. We know we're talking about a large number, and we're going to move it 6 places to the right, which means I'm going to have a 25, and then I would have 1, 2, 3, 4 zeros after that 25. So how many pennies would have to be stacked? Well, that's basically 250,000 pennies. 250,000 pennies would have to be stacked. Does that answer make sense? Sure it does. Let's look at this one. So the distance from the Earth to the nearby star, Barnard star, is 7.6 light years, where 1 light year is actually 6 times 10 to the 12th miles. That's a lot of miles. How many miles away is Barnard star? So it says that it's 7.6 light years. So 7 of these. So it seems to me like I'm just going to multiply 7.6 times 6 times 10 to the 12th. Well, if you really wanted to, you could do 7.6 times 10 to the 0, because that's really what 7.6 is in scientific notation. Remembering anything to the 0 power is just 1. That might make it a little bit easier to understand. So I have to multiply 7.6 times 6. And I'm going to get 45.6 times 10 to the, add the exponents, and we get 12. Let's keep this one in scientific notation. This is not in scientific notation. I would have to move my decimal to the left 1, making that number smaller, which means I want to add 1 to my exponents. So it's 4.56 times 10 to the 13th. What am I going to label that? It's going to be miles. And there you go.